If data is very powerful, the place that stores data is also supposed to be very powerful. Uh, if the database is a powerful place, obviously the people who are behind the database developers are supposed to be most powerful people. But is it the reality? I don't think so, because it was a long time before that we consider powerful people come from powerful places. But I don't think we give enough importance to database developer as such. Why this happens is because if you understand, okay, data is directly related to business. Ultimately, data is the place where you do your business. Like if you are putting money into your bag, you are putting data into your database. Basically, that's what you are doing. But what happens is, this is how it happens. You have your databases, and from your databases, you need to go to your business. This is your business, and you can't directly go. For that, you depend on the languages. When I say languages, we have some really great open source languages. Intentionally, I keep open source technologies here. Some people might wonder why I put C#. C# is also an open source, and they are coming good. So we have PHP, we have Java, we have C# and other languages. So they are the first line of defense. And then you have frameworks. They will help you to do your task effectively. And these are really great frameworks, and we should be really thankful for these frameworks. So one is MyButters. They take a different approach. They are called SQL mappers. They map your SQL, they manage your connections and all those stuff, and then they do your task. And then we have Hibernate. These people are like ORM, object relational mapper. They map your tables to objects. So it's kind of object-oriented programming. And then it finally gets into the business. That is, you develop your applications. It's all look fine, but the problem is the database developers that we are talking about. The bad part is, it's not that they are out of the game. They are not even in the picture. They are not even that's the problem that I'm seeing. Is that something that we can easily eliminate? No, because you come from any language, you come from any framework. Ultimately, it's SQL that gets into the system, and it is SQL that comes out of the system. And it's important that we have control over it, and we fine-tune it, we optimize it in such a way that it provides us the actual right expected results. That's the idea. So now this is there. We'll see how this evolved over the period of time. But we'll start with the session now. So I'm talking about somewhere around 2003 how database market was. It was like a small railway station. You have two major tracks where passengers will come in and go. These are all your enterprise databases. I'm talking about the time where open source is not considered as a serious business. For example, if you consider a railway station, all your major platforms are your enterprise softwares. And the right side, you see the corner side, there is one track that is not for passenger. It is for just changing the train and all the stuff, halting a train. That is the place where we place our open source databases like MySQL and Postgres. Things changed from there to today quite enormously. Today's database market is something like this. You have quite a bit of players. It's not just relational. Now people say, okay, you tell me the data. You tell me the type of data. I'll tell you what is the database. That's a stage. But earlier it was like, we'll say, what is the database that you use? Oracle, MySQL, DB, or DB2. I think everything was relational databases. There was no competition between type of databases. But you have competition with type of databases today, and different database vendors also today. So market is kind of clumsy. It changed. The idea that you need to get is it changed enormously. Okay, fine. Now, why people first of all migrated from relational databases? It started around 5-6 years before, or 10 years before, where people started getting frustrated with relational databases, and we were complaining about relational databases. People migrated to a movement called NoSQL databases. There is no clear definition of NoSQL databases. Broadly, NoSQL database is something that are everything apart from relational databases. That's how you need to see it. Okay, but now why people first migrated? The reason for migration is one, these relational databases are there before even cloud, all this new things came into picture. Because earlier days we used to develop softwares with vertical scaling in mind. That is, if I write a software, how much of maximum hardware utilization that I'm going to have. That is what I was concerned about. So we are using it for vertical scaling. The software that can scale, say for example, if you have 2 GB of RAM, how powerful my system compared to your system in that 2 GB of RAM. That is how everybody was competing in softwares. But things changed. Nowadays we are talking about horizontal scaling. I don't care how you perform in one machine. As long as I can share the workload across the machines, then I'm fine. That is the style that we have today. And these relational databases were not made for that. And that's why we see that databases cannot scale, relational databases cannot scale. And that was a complaint that we had. That's one. And the second one is most interesting limitation. relational databases are structured, and people are really frustrated that they are structured. The reason they are structured is when you define your databases. I mean, if you want to put the data into your databases, you need to define it. You need to say what is the table, what is the relationship, what is the primary key constraint, what is the foreign key constraint. You put all the checks before the data gets into you, and that's kind of people get frustrated because I want to change my application. Things has to be dynamic, and then it's not that developer friendly. Okay, that's okay. That's a problem. But now we are coming to the today's world. I hope everybody is part of this. Everybody is part of this journey, digital transformation journey, and we all are trying to do that. I'll just take a small deroute from here. Before we understand the databases, we will just take a deroute of what happened in adjacent worlds. I'm just going to take a civil industry. In civil industry, what happened is, if you see nowadays, the construction projects that we put are constructed pretty quickly and they are of good quality also. The reason that we do that is because there is one, apart from a lot of other changes, there is one significant movement that has happened is this. If you closely watch the high-rise buildings or new bridges that we see, you see this model where the blocks are already made outside your places. You earlier used to build your blocks in your construction site. Now the blocks are made outside and they are tested, they are fine-tuned, they are optimized outside, and then they are just fit into the original site at the construction level. So construction site is just a fitment site. It doesn't do things. It's all well tested, well proven components, and that is the place where our friend in web scored. Welcome to the web components world. If you are familiar with UI, so you know what is the pain that you will have with frameworks. So this is how web market was earlier. So you have your browsers and you have your HTML. And you have your frameworks like React, Angular, Vue.js. They do a lot of their own way of doing things, and finally they get into a composed HTML, and the composed HTML gets rendered in browser. Now people started thinking, why should I be framework specific? And then web component is kind of a reusable component structure, and they give a vendor neutral way of defining your components, which are like can work independently as well as together. And if you match that with SQLs, and this is, I think, the mistake that we are doing. If you look at the problem, if you just relate it, browser is nothing but your databases, relational databases, and HTMLs are nothing but your SQL. So if you have your languages, yes, PHP is a good language, Java is a good language, C# is a good language, but standard query itself is a language. If these languages can understand and then they can make their adjustments out of SQL itself, it makes our life better, and then I can port it across multiple languages. That is the idea. Now coming back to our story. Okay, we are going to start our digital transformation now. Once we start the digital transformation, particularly I'm talking about people who are using this legacy kind of relational databases, we need to first understand the relational databases today, because the relational databases today is not the one that we had earlier. They changed left and right actually. They are far more superior actually. Let us look at the aspects one by one. First thing is cloud readiness. Now you can see you have this modern databases like Google has Cloud Spanner, and then you have PostgreSQL, which was once not even considered as a main database. Now it's one of the topmost relational databases in open source. And you have CockroachDB. That's a very interesting database. They scale across the regions. And then we have one presentation also from Oracle, where Oracle provides an enterprise cloud database. So basically, these relational databases are well within cloud kind of environment. That problem is no longer there. But the second problem, okay, so how do we solve the problem? For the second problem, it is actually structured. But if you look at it, I just changed the font colors. Something that I see as a danger in red, but I see that as a green, because people started realizing that being structured is not a problem. Being disciplined is not a problem. It's actually a gain. It's actually a gain. Okay, so now how it is a gain? Just let us watch these three words. I think these three words are most powerful. Standard, query, language, and then take that query word. Query is something that you query your data, that's one, but then there is another query. You can query your relational data and get the metadata. When your database is set up, it gives you a lot of information about your tables, views, constraints, types, stored procedures. There's quite a bit of information. These databases expose information to business developers saying that, guys, I have these many checks for you. Please utilize it when you write your business logic, which means if you consider it from a data engineer or a data scientist, you have a structured data source. If you have a structured data source, you can get the metadata and you can apply your intelligence and get something wonderful. And see that something wonderful is nothing but your code. That is what I'm talking about, cross compilation. So if we can have an approach where we can do this, then it's going to be powerful. But now let us just revisit our approaches today. Because today's talk, I just want to focus on our approaches. It's not about any specific frameworks. Frameworks are great, actually. Frameworks, languages, tools are great. But the approach is the problem that I see. The approach today is, this is the approach that we have. You might wonder, I have not changed the slate, it's a mistake. No, it's not a mistake. The change is there. If you haven't noticed it, there is a change. There are some new people that is coming in. That is, this is really a good, if you're coming from Java background, probably, if you have not looked at JavaOQ, please go and look at it. That's also kind of an open source tool. But they come with a new approach. What they provide is, after Java 8, we have this functional programming, all that streams and all those stuff becoming more powerful, and they capitalize on that. Java is no longer an object-oriented language. JavaOQ helps you to create streams kind of a databases. So that's okay, but still they enhance on top of a specific language. They are very specific to, say, for example, Java. We are still bound with the same old problem where still the database developers are not even coming into the picture. Now, the second approach, which I don't know many of you might have explored, but most probably will explore it in future. I consider somewhat this is very related to microservices, where people jump into this conclusion without understanding whether this is useful or not, but later they will realize it. So REST and GraphQL. There are some modern magic solutions where you give your databases, they get the database, get the metadata, expose them as a REST APIs. Okay, good, it's nice features, but what is the use? Because SQL is an underlying skill. It's not just exposing my table as a REST, it gives me more power, because table is just a table. It doesn't contain my business. I need to write a lot of business on top of it. Where do I write that business safely? And that is a play. But having said that, these platforms are a great tool for use cases like ERP or content management system. These are all great tools. But the point is, this is not a tool for all the problems that we have. If you are using it for the wrong problem, then probably this is a problem. Okay. Now coming to our thing. Now let us just look at a simple hello world of how a database visualization is. Consider I have a movie database, and I'm looking at I'm going to get an actor from the movie database. What is my perspective? So this is the select query. Select actor ID, act name. That's all database related items. But when I see it from an object-oriented background, I say I have an actor model, and then it has actor ID, actor name, and then I'm going to search with actor ID, and I might use JDBC or I might use Alibaba or something like that. That's the conclusion that I have. Let us look at this playground, how I visualize it. So now this is what I would like to do on a high level. I am looking at, I need a new application, and in my application I am going to connect to Postgres, okay, and then I need to understand what is the database. So I understand the Postgres database, and then I say, okay, I want to map my understanding, my knowledge to Java. Okay, all set, let me write my code, and that's what I'm saying. Now I'm just going to play my idea. So now once I play my idea, so it just connects to Postgres, understand Postgres, extract the metadata, map that to Java. It might be C# later, it might be PHP later, and then it writes the code. Okay, now I'm getting into my site. So this is your factory. This is your factory. Okay, now in your factory you written it, tested it. Now let us get into the main site. So main site is this. So in the site, what I'm trying to do, I want to do my business. So I want to get an actor. So how do I get an actor? I need actor DO. Okay, someone has implemented. So now I'm saying new JDBC, and this is the place where I can, as I generate the code, I can go to the lowest possible level. The lowest possible level in Java is JDBC. So I go with plain JDBC. And if I go to Postgres JDBC, I need to connect with my Postgres data source also. Okay, all set. Let me do my task of getting my actor. I'm just going to get the number one actor here. It's a long, so I say one long, and then I say that get my first name. So let me play. So it says, okay, I connected to your movie database, and then I got you the actor. The number one actor is Rajnikant. Okay, good. Okay, now what I just did is, we get that SQL, understand the SQL, and then consider that SQL is one component for you.